So in this lesson, we're going to discuss the cross product formula for curvature. And this is a fairly intricate algebraic argument, but I will do my best to make it as clear as I can. So let's start with the unit tangent vector. How is it defined? The unit tangent vector is in the same direction as the velocity, but it's got length 1. So it is the velocity vector r prime of t divided by the magnitude of r prime of t. So that's something we're going to need to know. But in the world of vector valued functions, speed, r prime of t is the rate of change of arc length with respect to time. So speed is just ds dt. Well, if that's the case, then I can substitute the ds dt here for speed, which enables me to rewrite this equation as t of t is r prime of t divided by ds dt, which then sends us where? Well, if I multiply both sides by ds dt, that would give me t of t times ds dt equals r prime of t. But I want to think about it as r prime of t, so I'm going to write r prime first. So r prime of t is going to equal ds dt times t of t. So we have one way for us to look at the velocity function. So the next phase of our argument is going to be looking at the acceleration. So what is the acceleration of t? That is the derivative of the velocity of t, which would be the derivative with respect to t of ds dt times t of t. So how is that going to work? What's our strategy here going to be to go ahead and evaluate that derivative? What tool do we need to use? Well, it is the product rule. So using that product rule with u and v, u is ds dt and v is t of t, so v prime is easy. V prime is the derivative of t of t, which is t prime of t. Now, how about u prime? That is the derivative with respect to t of ds dt. The derivative of the derivative is the second derivative. So u prime is d2s dt squared. So putting that together, then, what is my acceleration of t going to be? It's u prime v, so d2s dt squared v of t, or v, t of t. So u prime v d2s dt squared u prime v times t of t plus uv prime plus ds dt times d prime of t. So I have acceleration here, which is good, and I have velocity up there. So let's take a look at these things. Let me go ahead and rewrite this then as v of t, just because I'd like to move to v and a to help me understand where we're going to go next. So the next step's a tricky one. This is the cross product formula for curvature, and the way I'm going to get it is by taking the cross product of the velocity with the acceleration. So I'm going to take v of t cross a of t. What's that going to be? V of t is up here. V of t is ds dt times t of t. Cross a of t. Where is a of t? A of t is all of this. So a of t will be that second derivative, d2s dt squared times t of t plus ds dt t prime of t. And I admit this looks nothing like a cross product formula. yet somehow we have to get there. So let's go ahead and collect our information that is relevant and do the analysis we need to get the curvature. And here we are, and the cross product distributes the way we would want it to, and we can pull the scalar values out in front. So handling this part, cross product of this piece with this piece, what do we get first here? So we have V of t cross A of t. What do I get? I have ds dt times d2s dt2 t of t cross t of t. Now, what is that going to be? Can you think about that before I move on to the next piece? Plus, do the cross product this way, ds dt t of t cross ds dt t prime of t. So we have ds dt here, and we have ds dt there. That'll be ds dt squared. Then I have t of t cross t prime of t. And again, let's go ahead and focus on that part. So what do we know about t of t cross t of t? They are parallel. The magnitude of the cross product is the area of their parallelogram, but if I have two vectors that are parallel, there is no parallel. If two vectors are parallel, their cross product is zero. So this first piece just becomes, this becomes zero, so this whole piece becomes zero, which is nice. So where does that send me next then? We'll say V of t cross A of t is ds dt squared times t of t cross t prime of t. Okay, so what's our next strategy? We're going to take the magnitude of both sides, magnitude of V of t cross A of t is the magnitude of ds dt squared times the magnitude of t of t cross t prime of t. And really, this would be better as absolute value than magnitude because it's a scalar, but we get the idea in terms of what it means. And do we remember what the magnitude of a cross product is? ds dt squared doesn't need absolute value because it's always positive. Times the magnitude of u cross v is what? Just cleaning this up a little bit. The magnitude of u cross v, let's remind ourselves. The magnitude of u cross v is the magnitude of u, magnitude of v, sine of the included angle. So using that rule up here then, we get the magnitude of v of t cross a of t is ds dt squared. Again, no need for absolute values. Since it's squared, it will always be positive. Magnitude of t, do you know what that is? Times the magnitude of t prime of t. Do you know what that is? Times the sine of theta. So here we are. So continuing in this vein, magnitude of v of t cross a of t is ds dt squared times 1, magnitude of t is 1, times the magnitude of t prime of t times the sine of theta. But what do we know about that? Do we recall from earlier that t and t prime are orthogonal? Do you recall why that's the case? Magnitude of t is 1, t dot t is 1, take the dot product. That tells me then that t dot t prime plus t prime dot t has to equal 0 because the derivative of 1 is 0. So the angle between t and t prime is 90 degrees. So I get the sine of pi over 2. So this is 1, and this is 1, which brings me to this very important line. What do we get? We get the magnitude of v of t cross a of t is ds dt squared times the magnitude of t prime of t. So that is going to be a key piece that we're going to need to develop our formula for the curvature. So we're here, and what I'm going to solve for is the magnitude of t prime of t. So dividing both sides by ds dt squared, or speed squared, what do we get? We get magnitude of velocity cross acceleration divided by ds dt squared, speed squared, equals magnitude of t prime of t. But how do we finish this? Remember, our goal was to get a formula for curvature. What was curvature? How was it defined? It was the magnitude of dt ds, which was the magnitude of dt dt over ds dt, which is the magnitude of t prime of t divided by ds dt. Or put an absolute value on there if you want, but typically we think of it as positive. So if that's the case, then can you see all we have to do here? We're going to stick with this formula. Curvature is the magnitude of t prime of t divided by ds dt. We're going to assume it's positive as we're moving through there. And then how do we make our substitution? T prime of t is right here. We see this formula. T prime of t is the magnitude of velocity cross acceleration divided by speed squared. So we get the magnitude of v of t cross a of t divided by speed squared, all divided by ds dt. Well, so times 1 over ds dt. So what does that give us? That gives us velocity cross acceleration divided by ds dt cubed, which is a perfectly good formula, but I like to remember it this way. Velocity of t cross acceleration of t divided by the speed v of t cubed. That is our formula for finding the curvature using the cross product. So let's quickly look at an example to show you how nice and easy this formula is to work with. So an example we looked at in a previous video was this parabola. R of t is t squared. But if I want to use a cross product, I've got to make this a three-dimensional vector. Well, that's not a problem. Can I get velocity? Velocity is the first derivative. That's what? 1, 2t 0. Can I get the acceleration? What is the acceleration of t? The acceleration of t is 0 to 0. I need to get v cross a divided by speed cubed. What is v cross a? We go I, j, k across the top. 1, 2t 0, and 0 to 0. What's that going to give me? And it goes plus minus plus across the top. In the I direction, 0 minus 0. In the j direction, 0 minus 0. In the k direction, 2. So v cross a is 0, 0, 2. No need to work on that very hard. So the magnitude of V cross A is 2. If you like 0 squared plus 0 squared plus 2 squared is 4, square root of 4 is 2. But maybe it's obvious the magnitude of V cross A is 2. How about the speed? What is the speed? The magnitude of V of t is the square root of 1 plus 4t squared. So what's the speed cubed? It's 1 plus 4t squared to the 3/2. We'll put them together. What do we say curvature is? Curvature is magnitude of V cross A divided by speed cubed. Magnitude of V cross A, 2, divided by 1 plus 4t squared to the 3/2. And a very challenging problem becomes extremely simple using this cross product formula for curvature.